So this is an introduction to the video with Dr. Tolou Shokuhfar at the University of Illinois, Chicago. The video was done on Skype. Bioprinting is a mechanism which includes software and hardware for the design of living tissue and organs. The field originated about 15 years back, but significant advances over the past few years have got us to a stage where artificial tissue is being used widely for research and development, for drug development, and some early experiments in organ development are also showing promise. Now, there are about a dozen firms in this space, but it is still early days. Gartner, a research firm, predicts that we are about 5 to 10 years away from maturity of this field, which quite frankly is not too far out. The scale of some of the tissue that people are able to create and use, and this is available commercially as well, is still very small. And as we look at 3D printing organs, one of the biggest obstacles researchers face is to overcome the challenge of figuring out creating 3D printed blood vessels. So let's find out more from Dr. Shokuhfar about advances in bioprinting and her own work in the area.
My name is Tolou Shokuhfar. I'm Associate Professor of Bioengineering at the University of Illinois in Chicago. I have two major research areas as a focus of my research lab, which is in situ bioelectron microscopy of biological tissues and proteins for diagnostics of disease, as well as nanomaterials and biomaterials for regenerative medicine. This is a focus of In Situ Nanomedicine Laboratory, which I'm the director of. We have 13 students consisting of 6 PhD students, 3 masters, and 3 students working in this lab. As a main focus of my bio-nanomaterial research in nanomedicine, I also work with 3D bioprinting for regenerative medicine. For many years, 3D printing has been started, and it has brought a lot of amazing application in different fields, such as aerospace, from anything actually we can make. So basically anything that you can have a blueprint of it, you can basically make it nowadays. It makes even some ideas that once a day probably was a science fiction into a reality. Just giving you an analogy for a very interesting and recent work currently actually in the theater is called The Jungle Book. That distinguishes us, how the boy shows what it distinguishes him from any other species is that he is a builder. So by nature, as a mankind, we are builders. So now how we can take advantage of that capability and bring it to the next level and next ideas? Well, that's the possibility that making and 3D printing can give us. So now think about, you can actually make anything that you can make a 3D blueprint out of it. Can you possibly make something living? So that is the idea. Can we bring the idea of 3D printing into 3D bioprinting? So what bioprinting is, in simple word, we can say, well, now instead of building constructs or devices or other new technologies that 3D printing is nowadays used for, how about we try to construct something that is used in the body and a living system? With this, we can even categorize the 3D bioprinting systems. Either we can 3D bioprint a scaffold and then use that to replicate or replace parts of the body that is unfunctional. Or we can actually print living cells and then use that to actually replace an organ that is not functional. Well, I have to add that the second part of it is way down the road and is the future idea of 3D bioprinting that everybody is hoping to achieve. But for that to be possible, it can bring us a huge, wide, applications. It's very fascinating. It comes back again, if I wanted to put it some simple word, is printing living cells. These living cells could either be from a patient itself, from the human body, patient itself, or they could be from the stem cells. To keep them alive, you need an environment that can best mimic the environment of the actual tissue or human body environment. Nowadays, you might have heard like injectable hydrogels that have been already used in many disciplines within the medicine. Those can provide very good environments for cells to be alive and start replicating. So here I am talking about development of that specific ink that we kind of use it with a general 3D printing, but here we're using it as a bio-ink. This means that you have an ink that has the right environment for the cells to grow, and then you also have the cells within them. So you can think about there are a lot of aspects just within the development of this bio-ink that is crucial. You need to have the right density of the cells, the right density of the material, the right properties of that bio-ink material. It kind of serves as a matrix that can later on develop to an extracellular matrix. But also you can tailor the property of the bio-ink to provide the functionality and the purpose of what you want to print out. If you want to print out an avascular tissue, if you want to print out an organ, if you want to print out a device that could be used for drug screening, those, depending on each of the application you're looking for, you can tailor the properties of your bio-ink to get to that aspect. Going back again to 3D printing of scaffolds, where you do not have any cells, that is actually a more approachable application of 3D bioprinting right now, because you don't have to worry about keeping the cells alive, keeping them functional, providing the environment for them to basically replicate what they have to do. Rather than that, you can actually print a part of the body that is missing. For example, scaffolds for bone. Those could be a good examples. Right now, titanium alloys, or other cartilage replicating hydrogels are used. They don't come with cells, but they kind of need to be used for maxillofacial implants, for total hip replacement, total knee replacement. Even for lower jaw replacement, replacement of teeth. So you can actually use 3D bioprinted product to replace the currently implants, with which can actually use these 3D bioprinted products to better mimic the properties and the shape of the implant. You can even take CT scan of skull, and if there is a case of accident for maxillofacial injuries, especially even for warriors or in warfare, and for veterans also, that could be used. So you can make a 3D scan of the missing part, and you can really replicate with all the detailed missing part the construct from a biologically compatible biomaterial, and that could be replaced for the missing part, and the human cells by themselves, the tissue by themselves can encounter the whole scaffold and try to regenerate and mimic the construct. So as a summary, I would like to say that 3D bioprinting is the next generation, which we all look forward to it. It has two concepts behind it. One, either you can print biomaterials that could be used and implanted within the body, or you can actually print cells with the mimic extracellular environment that could actually mimic an organ or a tissue in the body. So as a general introduction to 3D bioprinting. So we are working basically with two, I would call three main aspects of it. My research is not going to be focusing on replacing any organ at this point. However, I would like to point out that actually about average of 18 people die every day because of not having a functional organ. So, and right now there are a lot of donors and that's the way to go for it. But for having a functional organ, you may not even need to replace the whole organ itself. You might be able to kind of replace a part of the organ or tissue that is not functioning well, and that will help the organ to gain back its actual functionality that is important for immortality, actually, I would say. So my research for now, we are focusing on two aspects. We are working on developing certain type of scaffolds and with a specific bioink, development of that specific bioink that can help the regeneration of nervous system. So we are incorporating and developing our actual matrix, which would be also an hydrogel-based matrix. We are incorporating some components which are compatible. Like if you think of it as if you think of a bioink as a nanocomp or a composite material, we have that hydrogel base. We have other components that can provide electrical conductivity. They could be graphene based, which we're incorporating them as well as stem cells. And an additional to that, we change that the stem cells in some other cases, different bioinks, to astrocyte cells. And then we can apply electrical impulses to help and stimulate the regeneration of astrocytes, then to have a proper axonal regeneration. We are aiming in the future to have this wirelessly controlled. So if you think about cases, for example, for spinal cord injuries, if these could be even placed in the body and wirelessly controlled to help the regeneration of the damaged nerves and tissues. And in addition to that, we are also starting to work with the GI system that could be essential and very important for toxicology studies. So where it's right now, a lot of drug development, drug discoveries, $1 billion industry right now is suffering through really coming up with a good method to do discoveries of the drug. Right now, I would say, well, they have to go through animal studies and then clinical trials. And many of the cases, the drug is actually would fail in the case with the animal studies and would not even get approval for further studies. And there are a lot of costs and other ethical issues related to that. So now, if we can actually have a custom-made tissue that can replace or replicate what is going to be used for toxicology studies of drugs, that could open up a huge route and avenue. And there is a lot of interest in this. My research group specifically is working on GI tract, and we are hoping that we can rebuild a 3D bioprint system that replicates the GI tract, and it could be used for drug screening as well. As the last example of what we do in the lab, We are working with manufacturing 3D printed scaffolds that could be used for lower jaw or maxillofacial reconstruction. That is extremely valuable for the cases of traumatic injuries, even accidents or war cases where the patient actually loses a part of the maxillofacial system, if it's a lower jaw, even front teeth, or a skull bone. So in this case, we are not bioprinting any cells. Rather, we print an environment consisting of hydroxyapatite bone-forming environment that can replicate those missing parts. And even it could go even to a smaller aspect of the work. For example, in the elderly patients, when they do not have a good healthy bone anymore, the jaw starts to lose the construction and how the configuration of actual faces. And that case, some of them cannot have dental implant replacement, or they cannot have the sensitivity of that. With this new 3D printing products, we are hoping to overcome that and regain or keep the construction of the face or the maxillofacial part of the face. So that's one of the last aspect of the work that we do in the lab. The future of bioprinting and the main whole beautiful idea is to maybe at some point we can save lives and really print organs that are not functional at this point, helping people that need today donors of organs. But that's way beyond, because but that's a beautiful future which I see for it. But the way it works is you first have to keep the 3D bioprinted cells viable. Then you have to let them work, actually the nature work its way by, once you have the 3D printed tissue or organ, which could be either layer by layer or other methods within the 3D printed. Once you make that functional, printed, the nature takes place and the cell starts to regrow and form a tissue, and the tissue form the organ, but then you have to keep them functional. So today, it has been possible, for example, to 3D bioprint a kidney or a liver. You look at it, it actually does look like or feel like, coming from a cadaver, like a patient recently, passed away, but is not really functional, is not working as it's supposed to. So that's the future. So to really take it to the next level, overcome the barriers, overcome the milestones right now, and hopefully make that bioprinted tissue or organ a functional organ. And that right now requires a lot of advanced methods. You need to have, in addition to, a software for 3D bioprinting of that, a way to actually get the cells from the patient itself for regenerating the whole stem cell. Then you need to have the right bioink. Then you also need to have the right 3D bioprinter with that is compatible with the mechanical properties of that bioprint to 3D print it. Then after the 3D printed construct or organ that has formed, now the cells need oxygen, they need vascularization, they need a living environment. So you have to be able to provide that living environment as close to the human body as possible. A bioreactor, which right now is still not at the, requires further development, the bioreactors by themselves. Then you have to keep the stimulating the environment of the human body to make it actual functional. Now hopefully if that's functional, you need to make sure it's well replaced and it can be kept functional. So that's within maybe a couple of decades later. But maybe in a further development, you can have smaller cases of this part of these tissues and part of the organs, which will be tissues. You can try to keep them functional and make them functional, keep them functional, and then use them in smaller cases, for example, tissue graft, to make sure that they can provide the properties that is looked for in future. Again, for future application, I would like to mention drug screening would be amazing if it's possible to get to that point where we really don't need to, go through all the required steps that may even fail in some points. We can have even an organ on a chip or a natural organ that we can use for drug testing and drug screening. We don't need to go through a lot of animal studies from small scale all the way to big animal studies. We then can avoid a lot of unnecessarily required human trials, and then we can get to where we look for. Even beside, I would like to say, even beside bioprinting used for medical field, we can think about bioprinting for resolving hunger in the world. And you may say, how is that possible? Well, there is recent work on 3D bioprinting of food. Now, if we want to further expand that, maybe we can provide products that is possible to replace some of the issues right now of lack of feeding for many poor countries. So there is a lot that I believe 3D bioprinting can offer us, and there is a lot that could be done in future. And I personally believe that something that might be coming from a Star Trek or science fiction is no science fiction anymore. Right now is just human creativity and how much we are willing and wanting to make that happen. As long as we desire and as long as we dream, I believe that's possible.